Prevention is better than a cure. Assalamualaikum warahmatullahi wabarakatuh. We are from Group Automatic Hand Sanitizer Dispenser, and this is our team that consists of 6 members. First Hafiza Jamila, next Nur Adlina, then Nur Shuhada Najwa, next Nur Ainun Mardia, Nur Amira Ezrin, and Nur Atika Nazura. Let us start with the presentation, shall we?
Problem statement and objective. Today, news headline and world story are all about virus that called coronavirus or COVID-19. The virus has spread rapidly across the globe. Until today, our country Malaysia also is struggling in order to control the increases cases of COVID-19 even after weeks of lockdowns. WHO has released simple precaution in order to reduce the chances of a person to be infected. One of the simple precautions includes to use alcohol-based hand sanitizer to clean hands frequently. In cases where hand sanitizer are prepared at public places, many people will share the same bottle at one time. People normally use physical touch to press the dispenser hand sanitizer. Thus, when many people touch the bottle uninitially, the virus also spread among the user. In addition, when there are many people use inconsistently, the amount of hand sanitizer is difficult to check. This only makes the replacement of the new hand sanitizer and stocking up in store hard to estimate. Apart from this, the objective of conducting this project named Automatic Hand Sanitizer Dispenser are to reduce the physical touch on hand sanitizer bottle in public places. Next, to create the automatically dispense hand sanitizer bottle with touch-free. Also, this hand sanitizer high efficient in quantity of the product which will only distribute a set amount of substance per motion activation that can minimize waste. And lastly, it will help in order to notify if the hand sanitizer is at a low level to refill. I will pass this presentation to Ainun Mardia.
Assalamualaikum warahmatullahi wabarakatuh to Sir Fauzi and all of my classmates. I am Nur Ainun Mardia will present the product description and details. Firstly, I will present list of components used and its function. I will start with other components used in the product. Arduino Uno R3 is an open source microcontroller which is a microcontroller board needs to be powered with USB. The board is equipped with the set of digital and analog input-output pins that may be interfaced to various expansion boards and other circuits. Breadboard is used to make quick electrical connection between components such as resistors, LEDs, and capacitor to test the circuit before permanently soldering it together. Breadboards has many small sockets on them, and some groups of sockets are electrically connected to each other. Resistor is used to reduce voltage and current when used in a circuit and to limit current flow. 12C module is an inbuilt 12C chip that converts 12C serial data to parallel data for the LCD display. It works as an intermediator between the LCD and MCU. A male and female wire are used to make a connection between the component and the Arduino. Also, it will flow the desired current to all components. Now, I will explain the input component used. This sensor is used to detect the movement nearing the hand sanitizer dispenser. The sensor will detect the user hand and send the input to the servo motor. This sensor can be used to detect the amount of hand sanitizer. Thus, the sensor has an array of exposed rays, which is read low when hand sanitizer is detected. The third component that is implemented in this project is output components. The green LED light gives a sign to user that the hand sanitizer is ready to be used. However, the red LED light will be turned on when the hand sanitizer level is low and required to be refilled. LCD is used to provide a user interface which is it will display hand sanitizer, please use me when it is ready to use. However, when the hand sanitizer is running low and it is compulsory to refill, the LCD will display hand sanitizer low level. Servo motor is a small device that has an output shaft. It will convert electrical signal to mechanical displacement of hand sanitizer through the dispenser pump. The servo horn will be attached to the dispenser pump and pull the dispenser. Buzzer is an audio signaling device. The buzzer used to notify the user when the level of hand sanitizer getting low. Now, let's watch a video of component setup of the product.
Hi, now I will be continue with the programming flowchart. This oval shapes over here indicates when USB cable connected to the Arduino successfully, and arrow over here indicates a direction of the program, and the rectangular shape over here indicates a process to be carried out. Over here that we will be checking the liquid level. Okay, the diamond shape over here is indicates a decision to be carried out, which whether the level of the sanitizer is below or upper 80. Let's say the sanitizer is below 80, indicates to no process, where the output will be getting the red LED switch on, and the buzzer will buzz, and hand sanitizer low level will be displayed on the LCD. It will go back to the process where it will check liquid level again. And let's say if we already refilled the empty bottle just now, it will read as the sanitizer level above 80. So it will proceed to the yes process where the output, the green LED will be switched on, and hand sanitizer, please use me, will be displayed on the LCD. The next process is detecting hand using sensor. The blue shade here as a sensor. So now we proceed to make a decision. Is a hand present over here? If whether the distance below or above 10 cm. Let's say if the sensor detect and no any physical effect, so it will go back to the process detect hand using sensor, and go back to the decision made. Let's say if the sensor detects hand, it will proceed to the yes process, and sanitizer will be on, and sanitizer will pour into the hand, and it will delay for 1 second, and after that the sanitizer will be off, and this is the end of the program, and that's all.
So now, I will continue on the circuit diagram. This is our circuit diagram. As you can see, we use an Arduino Uno board as well as the breadboard. Here is the ultrasonic distance sensor. VCC is connected to the power, trig pin is connected to pin 7, echo is connected to pin 6, and it is also connected to the ground. We move on to the LED. The anode side of red LED is connected to pin 5, while green LED to pin 4, and both cathode is connected to the ground. Next, servo motor. The signal side is connected to pin 3. It is also connected to the power and also to the ground. Here is buzzer. We connect the buzzer to pin 2 and also to the ground. Move on to the water level sensor. The signal pin is connected to analog pin A0. The positive is connected to the power and the negative to the ground. Lastly, we use 12C LCD display. SCL is connected to analog pin A5, SDA is connected to analog pin A4, VCC to the power, and is grounded. This is how all the components are being connected together. Now, let's move on to the coding for this project. First, I define pin number for the components. Next, I define the variables. Then I include all the library for the components. Here, I set trick pin, echo pin, red LED, buzzer, green LED as an output. Then I attach the servo to the servo object and set it initially to 0 degree. Then start the serial communication, initialize the LCD, and on the backlight. Here is the loop. This is the coding for the ultrasonic sensor to send and receive the wave signal. Then here is to calculate the distance and print it to the serial monitor. So, if the distance is less than 10 cm, then the servo motor will rotate to 45 degree, 90 degree, 135 degree, and 180 degree. It is rotated in stages so that it does not speed out. Then, it will delay for 1 second and turn back to its original state. Here is the loop for the water level sensor. First, it will read the signal from the sensor. If the level is less than 80, meaning that the water level sensor is not really submerged, then the red LED will turn on, green LED will switch off, and the buzzer will buzz for 1 second and off for 1 second. And the LCD will print hand sanitizer low level. Else, the LCD will print hand sanitizer, please use me. And the red LED will switch off, while green LED will switch on. That's all.
I will continue on the result that we will get after completing these mini projects. Now, let's watch how automatic hand sanitizer dispenser works. First, we upload the coding to the Arduino Uno. After successfully uploading the coding, we connect the USB to the power supply, which is, in this video, we use power bank 2 on the system. Then, the LCD will display hand sanitizer, please use me. And green LED will light up to notify the user that the automatic hand sanitizer dispenser can and ready to be used. When there is a presence of the user hand, the ultrasonic distance sensor will detect the distance of the user hand from the sensor. If the distance is less than 10 cm, the servo motor will rotate to push the palm of the hand sanitizer bottle, but in stages mode from 0 degree to 180 degrees so that the hand sanitizer will not pitch out. The servo motor will delay into 1000 microseconds. Then it will rotate back to 0 degree, and the spring inside the palm of the sanitizer bottle will return to its original position. The red LED will light up and the beep sound will come from the buzzer if the level of hand sanitizer is low. Other than that, the LCD will display hand sanitizer low level so that the user can read when to refill the hand sanitizer dispenser bottle. After finish refill the bottle, the green LED will light up and the LCD will display back hand sanitizer, please use me. Then the automatic hand sanitizer dispenser is ready to be used back. Continue on the discussion part. Based on the problems that have arisen in our country as stated in problem statements, this is what motivates us to do this project. The spreading of virus through hand contacts will increase the chances to get positive when tested for COVID-19. Thus, through this project, we can lower the rate of contact between human hands. This project requires us to use 2 input and 2 outputs, but we provide a smart system that consists of 2 inputs, such as ultrasonic distance sensor and water sensor, and 4 output, such as 2 colors of LED, LCD, servo motor, and buzzer. The variable that has been set initially is the distance of hand to the ultrasonic distance sensor, which must be less than 10 cm in order to dispense out the hand sanitizer. If the distance of the hand to the ultrasonic distance sensor is more than 10 cm, the system will not give order to the servo motor to rotate and the hand sanitizer will not dispense out. Lastly, this simple smart system can give a lot of advantage in order to curb the COVID-19 outbreaks.
I am Nosha dan Najwa binti Abakri. We will continue to make the conclusion for our project. What can we conclude from our study? So we particularly contribute in reducing the spread of COVID-19 virus, and all our objectives for this project are achieved. Let's recap the objectives again. Well, for the first objective, yes, we can reduce the physical touch on the hand sanitizer bottles in public places as the hand sanitizer is automatically operated, like mentioned in the second objective. Also, as our dispenser only dispenses on a set amount of hand sanitizer, it surely saves the usage of the hand sanitizer. Lastly, yes, our automated hand sanitizer can notify the user if it is in low level. So we can say that all our objectives for this project is successfully achieved. Thank you, that's all from us.